my initial starter code should hopefully give you an odd and even like game, and then you get to choose your dice game of choice. Some people have done Yahtzee, other people have done craps, 4, 5, 6, and other variants, maybe just sum of 4 dice or something, and they built on that. You have 2 weeks to do this, but there's a lot of moving parts. As you see from the starter code, it came from last semester, us working through it. When I had a bit smaller class size, so we had a bit more intimate conversation on where this all comes from, but notice it extends to like 3 pages. There's a lot going on. So some end results of what your game should look like. It doesn't show up as nicely on here, but people built on my initial 2 dice game. They did 3 dice. They did some kind of scoring system where there's a dealer and a bank. You either lose money or win money. Other people made their own dice and kind of visualized it as the traditional like dice patterns. They also implemented their own set of rules from games in their childhood or dice games they're familiar with. Other people decided to take a more animated route. So when you click on this button, the dice re-rolls, the guy jumps, and score is, I think, kept somewhere. Other ones, notice this, built on the starter code, and this looks for certain numbers. So the logic here is a bit hidden, and the code is very expansive that was built upon this. Like here, it's the lucky number 8 according to some Chinese culture, and thus we are rich. And some more examples from these. Okay. It's kind of questionable sometimes because everyone's suddenly coloring their canvases that lovely green color, and like, wait, Mr. Chen, are you teaching your students to gamble? I'm like, no, it's not gambling. It's just a game. We don't have any points. It's all make believe. So, yeah, it's their own kind of currency. So all this is okay. It is for your learning. So I will close this tab, and now we will. If you want to follow along, open up a new code pen, and then we'll talk about, okay, how can we get 2 dice and kind of get towards this idea of like odds and evens. So I'm going to code pen, I'm opening up a new pen, where is it, pen from template, new pen, make one, here. So this will be, and we'll make a demo code of dice game, or starter code. And let me show you where we want to go with this as I pull up my old pen. We will create something perhaps simpler or perhaps something more complicated. We are likely, maybe we'll continue this into tomorrow and we'll pause because we've already reached our cognitive limit for this Monday morning. We'll see. So I'm digging through my old pens to find you what we left off with last semester. This one. So from the assignment prompt, this is one of the simpler games. You have 2 dice, you roll them, you figure out the sum, check that if it's odd, do something, and if it's even, do something else. So this one is like, and I have a bunch of Wikipedia entries on, and they do a really good job of laying out the rules. This one was called Chohan. Yeah, this one. So we pretended we were Yakuza at the time. I guess that's the origins of this, and you can read about that. But basically, you have 2 dice, right? So this is the end result. You have 2 dice. When you click the screen, notice that it spins and it kind of rolls the dice. This one, it's odd in this case. Notice that this one doesn't have the choice between odd or even. It just checks odds numbers. When we get an even number, we lose. And each time we click the screen, it kind of repeats that behavior. Some new ideas is, okay, how do we get this stuff to display? Some old ideas is mouse pressed, drawing boxes, drawing random numbers. And maybe some new stuff for you is using text and seeing how that works. So far, so good? Know where we're headed? Okay, so before we start coding, this is one of our larger assignments, and I've not done so most of the time I hand it to you, right? But if you are starting from scratch, one really good idea is to kind of map out what are the parts and how do we organize this rather large program. So give me some suggestions. What are some things we'll need to do in order to accomplish this odd-even game? A students, do participate. Give me an idea, or just shout it out and I'll write it in comments. What, more time? Well, that's okay. Oh, modulus. Modulus. So this is a new modulus. Okay, so this idea comes from how do you check to see if a number is odd or even? That's going to be important. That's a really important rule in our game. Other ideas? Okay, so for sure we got to deal with we have to generate random numbers, right? Generate random numbers. And since we're dealing with dice, since we're making dice, they have to be from 1 through 6. No decimals, they're just whole numbers. What happens when we press the mouse? Yes, so when we press the mouse, what do we want to call that action? Then what happens, class? Oh yes, we have a chance of winning, right? We need to see the result. Maybe we then roll said dice. Any other parts that will be important? Yeah, Anju. A score? Right, so recording a score. Who's winning, how many times people have lost? Recording a score. So this idea, I'm just going to put in quote, parentheses, because we'll add on to that. We will get a functioning game first. Okay? So these 1, 2, 3, 4 things are what we'll deal with at first, and let's begin coding up some stuff. As with all kinds of processing or p5.js functions, we'll need to create a canvas. Let's make it 400 by 400. Let's make a background. I'll do my best to remember what green is. RGB, green background. We'll go add our favorite library, p5.js. Click, save and close. And now we should get a rough square being generated. Okay, we got our green background. Our program's running so far. What I have is just the setup function. I've created my canvas. I have my green background. Yeah, familiar? Second part, with all kinds of programs in p5.js in this class, we need a function to help us draw. Let's have a rectangle being drawn somewhere. This will serve as one of our dice. We'll have it in the upper left-hand corner. We remember that x goes across left and right. Y going positive goes down. Good reminder of that. So let's have it be 100 over, let's say 200 down, and it has to be a square. So we'll make it 100 by 100. Oh, a little bit too low. So let's have it go up maybe 75 instead. Ta-da. There's my rectangle. That's my dice number 1. First dice. Dice number 1. Below it, dice number 2. Draw a similar rectangle, so I copy and pasted that line. I want it to move down a little bit, so maybe I'll add 100 pixels to that. Da-dang. Oh, maybe a little bit more, 225. Add some spacing between my 2 dice. Drawing simple pictures. So far, so good. And then we'll go to one of the first ideas. Let's generate some random numbers. I think we've worked with variables enough. So since I need to store this number, also I have to manipulate it and work with it. I'm probably going to need dice 1's value up here, and then I need another variable to help me store dice 2's value. So I've declared them. Declare variables, variable dice 1 and dice 2 to help me remember what values these dice have. I'm doing excessive commenting just so that this will be helpful for you once I hand it off. And down here, let's initialize it. Dice 1 starts at, let's say, 1. Dice 2 will start at 2. Semicolon, semicolon. Watch the names. I'll pause and make sure my code has not broken just yet. I'll run it. I still see the same 2 white squares on the green background. So far, so good. So at this point, you should definitely have this run button appear. It's really helpful so that anytime you break your code, you're able to like kind of catch it. And especially for infinite loops, make sure you uncheck this enable box in settings under behavior. Let me zoom out ever so slightly. I've declared two variables at the top. I've initialized them down here. These dice start at 1 and 2 respectively. Forgive my spelling. Now, here's the interesting part. Dice 1, let's say we have to use the random function, 1 through 6, something like that. Dice 2, similarly, we have to generate this random number between 1 through 6. So that part may be new. Maybe in Game Lab you were using the random number function instead, and that really helped you put things in different places in many, many shapes. You could have used random to help you with position. Now, maybe a new part is working with this text function. So text function really is similar to a rectangle function. You need to tell it where it starts. This is like the upper left-hand corner. So I'm going to have it match my rectangle. And then it also has a length and a width. How big do you want your text box to be? Think about like in Google Slides or in Google Docs, you make a text box, so you have to drag it over and kind of stretch it or shrink it. It's that same idea. So maybe we'll keep it being 100 by 100. The one part that's new is you have to tell the text function what to display. Here, let me try just displaying the word hi. If I've done it correctly, it should display it on top of this first dice block. Let's click run. Ah, we see it. It is very small. You see it right here? Not the best, but maybe it will do for now. I've displayed the word hi. This function is working. It's very tiny. That's why you have the text size function. Notice the capital S. We'll make it way bigger, maybe 100 pixels. We'll click run, and there's our hi. You will see it now in plain sight. For the time being, text size works like fill. You don't need to declare it a second time. It just remembers what came before it. This one maybe it will be a hello. And just like before, I want to keep it on my second dice. The word hello will be displayed on that second dice, so I increased my y coordinate here. I click run, and then I see those words. Hello. Questions, comments? Not so bad. We've displayed words to the screen. Let's change these to numbers. So we notice that whatever is displayed here in this first argument, or this first letter number variable, is what happens up there. So I replaced hi with dice 1. Let's see what happens. We'll click run. Oh no. Oh goodness. Oh, please stop. Why? See, this is a bit odd behavior, right? Look, I keep rolling. I can roll a 1.34. I can roll so many numbers. That's not what we want. Hold on. Yes, an infinite-sided die. So there's some behavior that we do want from here. For example, if we covered up all these other, like the decimal points, we don't want that. We just want the whole number. So some very common pattern is with dice 1, here on my line 20 and 21, we'll have to round it. And here, I'm putting the round function. The round function is the outside part of the random function, and it's as you expected. When you have a decimal, just give me a whole number. And so now we just see the number flip-flopping between 1 through 6 for the most part, I think. So far, so good? We'll do the same down here, dice 2, run it. Now we have 2 dice that are infinitely rolled, not the behavior we just want. So we've done this part. We have a bunch of random numbers between 1 through 6. Let's start checking, okay, perhaps now we'll do the user interactions. Let's use if mouse is pressed. Actually, hold on, let me think, because I have to be careful here. There is another kind of function, mouse pressed. This function lives outside of draw, and this one is quite handy. Because now, if I say, for example, okay, this is ridiculous. I don't want to be drawing my dice all over. So in setup, I'm going to put down this no loop function. My screen is just drawn once, and it doesn't repeat anymore. So we don't want those animations to occur unless we tell the computer, when I click the screen, then you re-roll, then you animate yourself. Okay? So this is perhaps a new idea, a no loop function. Draw only happens once. Now down here, mouse pressed. Notice this function listens to whether or not the mouse is being pressed, and it lives outside draw. So even though draw isn't running, it can still detect that behavior. And what happens when the mouse is pressed? You redraw the screen. So now we have that kind of controlled behavior. I'm clicking on my screen, then we get these numbers. I want to contrast that with this one that you likely have used in your last program. Mouse is pressed. So this is some interesting behavior. I'm going to comment out these lines. Now I'm going to use this mouse is pressed function. Let's see if it allows us to redraw. So this stuff, line 27, if mouse is pressed, is what we've been using, and I don't think it works, but I may be wrong. Yes, I click run. Now if we use this function, when I click run and I'm clicking on the screen, notice it's kind of loud, it doesn't happen. So right now, because this draw function only happened once, it has no way to hear these mouse presses. No way to trigger that event. That's one key difference between this mouse pressed variable and the mouse pressed function. Okay? So these lines will go away. I wanted to highlight that point. It's very subtle behavior, the difference. Okay, so we have back our random numbers. The last part we'll add, and the final part is, okay, now we got to check if things are odd or even. So for now, let's just check, make it simpler. Check to see if dice roll is even, let's say. So that looks like an if statement. We have the numbers, 1 and dice 2. Maybe we'll do it even like var sum equals dice 1 plus dice 2. Now we're going to check to see if the sum is even. So if we divide it by 2, we should have a remainder equal to 1. And then we'll go use the text function and say it's even, and then have that down here maybe over so many spaces of size 100, 100. Let's see if that worked. Sum divided by 2 equals 1. So when I have 7, that's not equal to 1. Let me run this. 8, this should have triggered but doesn't. Wait, no, I did it wrong. Even, it's 0. Thank you. So here it is. Because we're checking if things are even, oh, it doesn't like to behave. Oh darn. I think my text may be off the screen. 125, run. Okay. Modulus. Oh, wait, no. It's, okay, perhaps we'll make it smaller. Text size is maybe 50 and 50. 50. Run. Do we see it? It's even. You have a somewhat functioning code. And then I hand this off to you now. Okay? The next part, because I've already talked at you a lot today, please make sense of this starter code. The starter code in the assignment is very similar, except it has more like functions. It gives you a button so you can do different kinds of behavior, not just mouse press. It also adds in a couple other things. It uses a custom function definition that I'll talk more to you about that tomorrow. Okay, I think that's enough for one day. So I will post this. And so here's a neat feature. I'm going to post this link onto Google Classroom. If you don't want to copy and paste all my code, you just click fork. This fork button will give you a copy of my code, but now you own it. And if you're signed into CodePen, it's your copy to mess with. So it saves you the time of having to retype this and follow along. Okay. That's all computer programming A. And I'll ask question. The percent sign, sorry. The percent sign, so I'm writing on the whiteboard now, it's also known as the remainder function. So, come on, markers, cooperate. Come on, fifth time. Okay. So, this is 1. 7 by 3, no, let's do 4, is 3. So the percent sign is the integer division, what's left over, the remainder function. It has a fancy name, it's called modulus. It's really useful in computer science. So that is really useful because when we divide things by 2, you should, if you're even, this is always true. You have no remainder. And that means if you have dividing by 2, if you divide by 2 and you have a remainder of 1, that means you have to be odd.
Wait, why can't you just do sum divided by 2?
Good question. I'm unsure. I think it's doing some kind of division that gives you a decimal, and that's not exactly equal to 1. So I tried that at first in my video, and it didn't work. So I will investigate that and follow up with that question another time. There's things going behind the hood